This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know How is brought to you by Rachio. Take control of your watering with the Rachio Smart Sprinkler Controller. It's Wi-Fi enabled to allow instant access with a mobile app and has automatic watering schedules based on the latest weather forecasts to save you water and money. Go to rachio.com/twit to learn more. And by DigitalOcean. Simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code KNOWHOW in the billing section to get your $10 credit. On today's show,
you'll know how to troubleshoot your 3D printer.
Welcome to Know How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Ballecer.
And I'm Bryan Burnett.
And for the next 30 to 45 minutes, we're going to be showing you some of the things that we've been playing with so you can take them home and play with them on your own.
Like this cuddly slinky that we have.
It's not a slinky. It's part of a very advanced... It's a slinky.
Robot arm?
Yeah, it's a slinky. No, it's... Can we do a show?
Danger, Will Robinson.
Do you mind
Danger.
if we do a show?
Sorry. Yeah, I guess we should do
Let's
that.
do a show. Okay. No, but seriously, we wanted to continue our 3D workshop. You'll remember last week we talked about some of the basic concerns that go into designing something, right?
Right.
Yeah.
From prototype till... Well, I don't think we've ever had a finished project
we
because it's an
probably never will.
evolution, but yeah, from beginning to end.
Last time we created a way to filter material using a 3D printed double-ended jar lid.
Yep.
This week, we are actually borrowing again from the upcoming Green Geek series because at some point when we're gardening, we're going to need to worry about airflow.
Of course, why not? And water too?
And light, maybe?
Yeah, probably a few things.
We are borrowing that from that project, but also it's getting to be summer, so I thought, why not show people a really inexpensive way to make themselves a ducted fan, a very decent ducted fan for just a couple of pennies that will run for pennies on the day, and that can be used next to you at your computer, or could, say, ventilate your computer to the outside world rather than dumping all that waste heat into your room.
Right, and I don't know how many episodes it was prior, but we did that swamp cooler.
We did.
Which was a lot of fun, but this sounds like a new way to cool things.
It's a new way to cool, and believe it or not, this is a lot simpler. Now, what we're going to be doing is I'm going to be using some of this. This is standard 6-inch aluminum ducting. I like this because it's inexpensive, it's actually pretty durable,
and it's fun to play with.
And it's fun to play with, right? You can do robot arms with this thing forever. A length of this is typically going to run you less than $20. So, I mean, you're talking about 25 feet. And actually, I probably chopped off 10 feet off this thing already. But it's incredibly useful material. What we want to use it for is we want to use it to exhaust hot air from a hot area to the outside world, so and maybe go from the outside world and bring cool air in.
Okay, so like behind my PC or something, where a lot of heat is generated and directed.
And what we want to do is we want to use cheap fans. These are 120 millimeter fans that you can get off of Amazon. We're actually going to show you links in a bit. Typically, they would be inside your computer case, but we're going to use them to move air through this duct. Now, back before the days of 3D printers, and when my skills were really, really lacking, I did a project like this where basically I just duct taped it to the end of the duct.
Right.
Don't do that.
What? Why would you not?
It kind of works, but it's A, it's super ghetto, and B, it's actually very inefficient. When you do something like this, you are wasting a lot of the energy, a lot of the air that a fan like this moves.
Okay. So not the most elegant solution.
No, and so I am going to show you an elegant way to do it. But first, let's go through the same goals, the same process that we used for last week's episode. Remember, we said we wanted to find a real-world problem. Well, in this case, our real-world problem is sometimes I need cooler air, sometimes I need hot air. I need a way to move air. That's my problem.
I would be impressed if you find someone who's already made a aluminum duct model to like clamp on with a...
Yeah, that doesn't exist.
Yeah, I wouldn't think it would.
Okay. Oh, we also need to beg, borrow, and steal as much as we can. Remember, that was one of the things that we said last week. Why redesign something if it already exists and if it's already on Thingiverse? So we're going to look on Thingiverse for something that we can use to give us a head start in this project.
And by steal, you mean somebody has done the grunt work
Yes.
for another project that they may have something completely separate for that idea, but we want to modify it for our own uses. It's not really stealing. It's like
It's
sharing
borrowing.
ideas.
It's flattery. If I'm borrowing your
Absolutely.
stuff, it means I appreciate the work that you did. I like the model that you created.
Huh. So you should remember that when I take your headphones next time.
No, that's
not stealing.
You'll be dead to me. Yeah. The other thing is we want to modify the existing STL. So once we download it, we need to. We're past the days where we just print something and then like Dremel out the pieces we don't want. We're going to modify it in our editing software.
I don't think I was ever in those days, though.
I was totally doing that.
Was that you?
That was me. It's like, I don't know how to edit this, so I'm just going to print it and then drill holes when I need it. No, I'm not going to do that.
That sounds, like a brilliant idea.
And the last thing that we want to do, and we kind of got to this last week, but not so much, is we want to revision. So we're going to print something, and then we want to make it better. And every time we print, hopefully we have an idea on how to make it better in the next revision.
Yep.
All right, so that's it. We know our goals. Our real world problem is we need to move air. The beg, borrow, steal, we're going to go to Thingiverse in just a bit. Then we're going to change it so that it interfaces with this ducting, and then we're going to make it better.
Okay.
All right, so first stop is Thingiverse. Alex, if you go ahead and drop over to my computer, we have our wonderful Thingiverse here. What I need to do is I need to find something that's going to work for our project. Well,
I'm already getting distracted. I want to print that T-Rex.
No, don't.
It looks so
don't.
cool.
No, this is better. 120 millimeter fan, because that's what we're going to be using.
Fine.
So if I bring this up, I've got a couple of options here. There are some projects that people have made.
That first one is like a little cheapo fan to blow in your face.
This is awesome. No, that's a soldering fume extractor. So you put this next to you as you solder, and it will pull the fumes out of your face.
Oh, okay. That is pretty smart.
Right. So it's sucking. It's not blowing.
Okay.
See, grow
Continue.
up.
What
Oh
is
my
it-
goodness.
what?
Okay. Oh, but the other thing that we want to look at is we want a way to mate the collar of this ducting with the fan. And most of these things not so helpful, but then I get down to this. And this actually holds promise. So this is a file for a 120 millimeter fan grill.
Right. So something that you might put on your PC or something because you wanted to make sure that your kids don't stick their fingers in the fans.
Precisely. But what I'm thinking is I can build a collar around that fan grill, and then the duct has a place to grab.
Yep. Okay, I can see that.
Okay, so that's the file that we're going to get. Actually, that is the file that we got. And if you go to the show notes,
So
it's
we need
already
to,
in our package.
We need to give props to NRP.
NRP, thank you very much. We're going to be using your 120 millimeter fan grill. And the next step will be to, make the docking collar. I'm going to show you a slightly different way of designing a 3D object. Okay. I'm going to do it in pieces rather than try to have everything in one sketch.
Yeah, things get pretty complicated when you try and do multiple void sections on a single piece in one Thingiverse project.
Right, so what I like to do is I like to try to get like the one part, get it perfect, get it exactly the way I want it, cement it so it's not going to change.
Make
and
it
then
its own model,
precisely.
and then do what you need in the next step.
And in this particular case, I've got a 6-inch duct. So Alex, if you go back to my computer, what I want to do is I want to make a cylinder like that. So that is going to be, if we look at our measurements here, it's 140 by 140 millimeters. It's actually slightly less than 6 inches. The reason why I'm doing that is because my build platform isn't 6 inches. It goes 5.9 inches. And also, if you try to put a 6-inch collar inside of a 6-inch duct, you're really going to have to stretch the duct to get it over.
That makes sense.
Yeah.
That makes sense, okay.
Because ultimately what we want is we want this to clamp down on the surface of the collar. So it has to be slightly less diameter so I can use zip ties or a clamp to hold it to the docking collar.
Okay.
Okay. So once I've created this, of course, a big chunk of material isn't going to do me a whole lot of good. So I'm going to make another cylinder inside of it. Now, we've done this before. It's hollow space.
Right.
Right? So all I've got is I've got one cylinder, and then I've backed off 2 millimeters. 2 millimeters, you can see it here. So that's
From the edge.
from the edge.
So you basically have a
1,
collar now.
2. Right, so it's the wall of the cylinder is going to be 2 millimeters thick all the way around, and the object is going to be 65 millimeters tall. Now that's not the limit of my platform, but I actually don't even need 65 millimeters. I could probably have made it 35 millimeters and gotten the same effect, but I wanted something a little bit longer just in case I needed flexibility later on in the project.
If you wanted to add more fans, or
Right,
something like
or
that.
if I needed more surface to grab with like multiple clamps.
I see.
Okay, so what I did is, if you go back, I'm going to download this for 3D printing, and I'm going to put it on onto my desktop. The nice thing about doing it this way is it now means that the design for this is locked in. That is not going to change, which means when I open up a new design, and let's say, oh, okay, that wasn't supposed to do that. When I open up a new design, I can import the collar that I just created by choosing the file. Where's my desktop? Where did that go? There we go. And import. And you'll notice it's a different color. It's white. Now, I can still modify this, but I can't change the original attributes. So I can't change the size of the empty space in the middle. But it also means I can move this entire thing as a unit without worrying about accidentally skewing the other attributes.
Right, or having to select multiple pieces and then, oops, I missed that one,
That's
and everything's offset.
Yeah. Right, exactly. But the other thing I can do is, let's go ahead and let's go to this. So this is what that looks like, but with that 120 millimeter fan grill at the bottom.
Right.
Right. Now you'll notice that there's this empty space again. I added another empty space. The reason why I did that is because I wanted to remove the inside of this grill. I don't need the grill.
You just want the holsters.
I just want the mounting points, exactly. Because if I'm putting something in the way of my airflow, I'm reducing my airflow.
Right.
And you're going to see why in a second, why I'm not going to need that. I don't need a grill for this particular project. In fact, all it does is add weight, it adds filament, and it adds air restriction.
Yeah, exactly.
Yeah.
Resistance.
Cool. So this is what I've got. I've got this collar. This is just that collar I showed you down on top of that grill that we got. Plus, I added this empty volume to remove the parts of the grill that would be inside of the piece.
Cool.
Okay. And now this is actually what it looks like. So we 3D printed this, and there we go.
We started it at the beginning of the show, and now it's done.
See, it's so nice.
Voila.
Look at that. So 2 millimeters is actually plenty strong. It will flex a little bit, but once you get the collar around here to restrict it, I mean, you could crush a metal collar before you crush the filament one.
Yeah, that's just the nice thing about circles and arches. Cool.
And this matches up perfectly. See, we've got mounting holes. This matches up perfectly like that, which means we should be able to take this. This is actually, see, this is why we made it smaller than 6 inches, because even at its current size,
it's almost a little too big.
And you want this because you want it to be tight.
Right.
Because if it's loose, it means that you're leaking air around the edges. You don't want to do that. You want your airflow to go where you're directing your airflow. You don't want it bouncing off of pieces of your assembly, which is the same reason why I removed that grill. And this is really, come on, get in there.
The struggle is almost as entertaining as how you made it. There you go.
There we go.
Yeah, so now there's less of a chance of air leaking out and making it far less efficient than it would have been otherwise.
Precisely, and this is what we want. So we're going to put the collar in here, and then I actually just use zip ties. So I put a big zip tie around this, and I just tighten it up, and I've got a nice solid seal.
That's cool,
Okay.
and now you can mount your fan to it.
I can put my fan on that. Now I can either be blowing or sucking air. I can be moving air through this duct quite easily.
Very easily. Keep
Stop
going.
smiling.
I'm entertained by your slug that you've created.
Alex, if you go ahead and go to number 4 under the tools required, I actually did show off a couple of fans that I'd be using for this project. The first one is a Cooler Master. We've got an Amazon link there for that. This is a 69 CFM. That is cubic feet per minute. In other words, every minute, this fan has the capability of pushing 69 cubic feet of air through its assembly.
Sounds like a lot.
Which is actually, for that small of a fan, that is a decent amount. Put it this way, the little grow tent that we're building for the show, it's something like 10 cubic feet per minute.
Oh, okay.
And the rule is you want to be able to exchange all the air in your tent every minute. And so this could do it 6 times over. You don't really, you don't need a whole
that
lot.
much.
Now you will lose efficiency because we're going through a duct and because there's angles and bends, but 69 gives me quite a bit of leeway there. The other thing that's important, Alex, if you go back to that, is the noise, because one of the things we want to do is we want to keep our fans quiet. This is only 19 decibels. This is quieter than the computer. So if you've got a laptop with a cooling fan, you'll hear that before you hear this.
Yeah, because the bigger the fan, the slower the rotation, the less noise it'll make.
Precisely,
But still be able to push a large amount of air.
That's the rule. The smaller the fan, the faster the blade has to spin, the higher pitch the whine, which is actually more noticeable. You could have two fans that have the same amount of noise, but one has a much higher frequency, and that's the one that will catch your gnats. Because a low frequency is just like a rumble. It's like the background noise on a Galaxy-class starship.
Which we enjoy.
We love that.
I would love to have ambient, enterprise noise in the background here all the time.
If only there was someone who could find that and then inject it into
I don't know if they would be
that might happen later
quick,
on.
but
now there is another one though. If you want something a little cheaper, Alex, if you go to the Arctic F12, this is actually a pretty good deal. This is a 5-pack. So if you were planning, you could actually put multiple of these fans with these columns.
Stacks.
Stacks on stacks. They're called boosters. So it's not like you're adding together the amount of air that they move, but you will, every time it starts to slow down because it bends, you can like reboost it.
Ah, okay, yeah.
Right. Because the problem is if I have this going all the way across my room, by the time it gets to the end, the air is just trickling out, right?
Right, so you could put little relays to continue pushing
boost the air, boost the air, boost the air, and it actually increases the efficiency for every fan in the chain because it's already got air moving past it.
Cool.
Yeah. Now those F12s, see, that's soothing.
Right?
Yeah.
I'm ready to go down to engineering.
Yeah. Actually, have you noticed that sound kind of makes you fall asleep? It's
like that white noise sound.
Yeah.
I kind of want that.
Now now we're building the Starship Enterprise fan. That's what this project is called. But those fans, the 5-pack, they're 74 CFM, so it's slightly more air movement, but it's also louder. So rather than 19 decibels, it's 25 decibels. So that is a significant amount more of noise.
Okay.
But the advantage of those F12s is you can actually run them at a lower voltage versus the Cooler Master, which only wants to be run at 12 volts.
Okay.
So you could turn it down and sacrifice some of your air movement for lower sound. Okay. Now we also need the ducting, and we need to do something else. There is an issue with the project that we just did. If you go to the overhead, Alex, you'll actually, maybe the side view is a bit better. If you'll notice, around the inside there, you see those
gaps?
Yeah, the problem is that the grill area is not quite big enough to exactly mate with the fan. So what will be happening is, as I'm trying to pressurize either side of this, that's going to be a leak. And remember, air is a lot like electricity. It will always look for the path of least resistance.
Yeah.
So rather than pulling through 25 feet of ducting, it's going to go, oh, there's a very low resistance path next to the fan. It's going to suck the air through there, or it's going to blow the air through there.
Could we just put some, I don't know, like tape or something
we
to
could,
block it off?
But you know what? Why would we do that when we can just make this better?
Oh.
Yeah, let's make it better. If you go back to my computer, Alex, so this is the design that we had. That's not bad, but now what we're going to do is I'm actually going to export this, just like I did with the docking collar, and I'm going to re-import it and do a few things. Notice how I've added these pieces down here.
Oh, yeah, little square offs there.
Right, so what this will allow me to do is I've built out that area so that when it goes on top of the fan, it actually covers all the way. And now I can just put a little bit of caulk, and it is totally sealed. That is an airtight seal.
Cool.
Yeah, the other thing that I've done, this is important, Alex, if you go back, I took a second instance of the docking collar.
You made like a little lip?
I made a lip, and what that lip lets me do is it means that when I tighten this with either a clamp or a zip tie, that lip will keep it from slipping off.
Right, so if it gets kicked or knocked or something like that. Very nice, good idea. But you have to be careful too, because there's only so much of a ledge that the printer will be able to do offset.
Precisely, and that's why this is only 1 millimeter.
Yeah, which should be fine.
1 millimeter is enough that it doesn't need supports to overhang, but it also is enough that if you have something clamped down, it's not going to slip off. Check this out. This was super easy to do. All I did was I imported that same docking collar, like this, but I imported it at like 104%. And then
you void off most of it, and then make it into a little...
Notice how, notice how it's a tiny bit bigger? What I did was I shrunk it, and then I just raised it. So rather than having to redesign a lip, I just did that.
Now it looks like Mario's tunnel.
Yeah, this is a warp tube.
Yeah.
Wop, wop, wop.
And so also something to probably point out with this project is if you tried to do print this upside down with the little standoffs.
Don't do that, yeah.
No, you want to start with the widest part at the bottom and work your way up.
Precisely. So what the finished version looks like is this. This is the revised version of our STL file. Now it has much wider flanges on the inside, so when I put it down on top of the fan, hold on, get it centered, there is no longer, you can't see any light because it perfectly covers that bit. Now, if I wanted to be really anal about this, I could put a little bit of a silicone here, so that it would create more of a seal. Because there's still going to be a tiny bit of leakage, but this is so much better. And this lip means that this ducting is not going to slip off. So here's what the finished project is going to look like. I've actually been printing a few of these. You're going to have a fan, you're going to have a collar, and then you're going to have another collar on the outside. So this will be a booster. This will be able to take ducting on both sides, so you can pull from one area and push out to the other. And you just make multiples of these. So if, for example, if you bought a 5-pack of those F12s, you'd print this out 10 times, and now you can have like 100-foot length of tubing that will have relatively strong airflow going all the way out.
That's cool. I like that.
Yeah.
And so you'll probably want to put one at every bend or close to a bend to pull through because there'll be more resistance there. I don't know. What would you say? How many would you have to put in? If you had 100-foot of the aluminum tubing, and it was just a straight line. About 5.
You can do about 20
so one
feet
on each
per.
end.
Yeah, and you'll still get about 50 to 60 cubic feet per minute pushing out of the other end.
Yeah.
There are a couple of other things we could do. We could use a smaller diameter duct. We could use, say, a 4-inch duct, which is a little bit cheaper, but I like the larger ones because it's less air resistance.
Right.
The other thing that I'm thinking about doing is actually making these, but with bends, with elbows.
Oh, an elbow, one of these. Okay.
Right,
yeah,
because
that makes
ducting, this is super efficient when it's going in a straight line, but the second you put a bend, I mean, think about this, the inside of this surface looks like the outside, so there's so many places for the air to like hit and bounce back.
Right.
Whereas if I made a collar with this, it would be smooth on the inside. The other thing is, if you can kind of buy pieces that are kind of designed for this, but you're talking between $6 to $15 per unit. Whereas when I printed this probably cost me about $1.50.
Yeah.
And I can get it exactly the shape, exactly the size that I want.
Very cool. It's a cool project, Padre.
It's a cool project. You will see this again because this will be one of the showpieces for our finished little grow tent.
Well, now I want to have this little tube from my office just blowing hot air onto the TD desk.
That can be arranged. Here you go. See? Oh, see?
Oh, yeah. That pushes pretty good in that air.
That's not bad. Combine a couple of these in series, and you've got yourself a nice little, very quiet air movement system.
The hardest part might be just powering all of them.
Yeah.
And linking them up.
Which is why we're not showing them that part, because we need to save that for that episode.
But if you're smart, you could power them all off the same source with the wire, and then maybe have an Arduino at the end of it controlling fan speed and velocity.
I mean, what I would probably do is I would probably just run the wires through the inside of the duct.
Yeah.
Make it super, super simple. And actually, I would put standard like JST plugs, so I could just daisy chain them.
Yeah, exactly.
There we go.
Cool.
And you kind of took my thunder because this will all be Arduino controlled, because one of the things that you want in both the grow tent and in your room, wouldn't it be nice if the system automatically turned on if the outside air was cooler than the inside air, and then turned off once the outside air is hotter than inside?
Right.
And that's what we can do with the Arduino.
Yeah, that's smart, because it would be a pain to have it on just all the time making noise, or, if it's not hot or your computer's not on and you're trying to direct the hot air away from your computer, it's just wasted energy. Yeah.
By the way, one of the coolest projects I made way, way, way back, like what, 30 years ago, I was tired of how loud PCs were. So I made an enclosure that completely, you couldn't hear anything. But the problem is now you have a very hot PC in an enclosed box.
Generating a lot of
heat, I
heat,
used a system like this to exhaust through the dryer vent. And it was, I mean,
it worked.
It was awesome. It's like it was sitting right next to me and you couldn't hear it. So we might do that too.
Nice.
That might be nice. When we come back, we're going to be continuing with our 3D workshop special. We're going to show you some of the printers that we've actually liked. We've played with about a dozen printers now.
We've broken almost the same number.
Actually, I've broken 6.
So for, that's a 50% death ratio there.
But the ones that have survived, they're pretty dang good.
And you're pretty tough on your 3D printers,
Yeah.
so it's kind of a good scale of reliability.
But you know what? I'm tough on my printers so that they don't have to be tough.
Exactly.
It's a public service. It's only because I love them.
That's right. He's doing it for you, folks.
Doing it for you. But before we get to that, you know what I want to do? I want to thank a new sponsor to the Know-It-All. So it's a brand new Kita. And actually, it's perfect because we're going to be doing the Green Geek episodes. And what's a nicer way to be a Green Geek than having an automated, smart watering system?
Yeah, I mean, not just in California, but just about everywhere. Water is a very valuable resource, and it gets wasted way too much.
Yeah, I remember the good old days when I was a kid, and watering the garden meant just plugging in the little lawn sprinkler and like maybe you forgot it overnight.
Set it for an hour, yeah.
Who knows, right? But no, now we want precise watering. We want smart watering. And more than that, we want watering that integrates with our smart devices. I mean, in this day and age, there's no reason why I shouldn't be able to pick up my phone and say, I forgot to turn off the sprinklers. Click, now they're off.
Right, or it's raining today, so I don't need to water my lawn.
Exactly, which is why we're happy to have Rachio as a supporter of the Know-It-Alls. Now, Rachio is a new way to think about gardening. The Rachio Smart Sprinkler Controller lets you control your home irrigation system at any time, at any place, from anywhere. Simply swap out your current controller with a Rachio Smart Sprinkler Controller connected to Wi-Fi and easily adjust depending on your weather. Now, you can stop stressing about manually unplugging your controller or changing the settings for rain. That's one of those things that people really dislike. You know, the whole idea of I have to change manually what happens when the sky opens up a little bit and drops some rain. Why not have a controller that does it for you? Well, that's exactly what you get with the Rachio. It's easy to set up using an iOS or Android application, and it connects with popular smart home applications like the Nest, the Amazon Alexa, Nexia, Control4, iControl, and more. You know, you can run zones directly from the controller, giving you or your landscaping professionals manual access, and LED lights give you a visual indicator of what's happening. This is one of the things I really like about this controller because it's not just going to work on your smartphone. It's not just going to work on the device itself. It works in both places. It's like combining the world of the traditional irrigation control and, well, the world of the smart controller. Now, with Rachio's weather intelligence, it will automatically adjust your schedules for weather events. If it's a little hotter, it will give your plants more water. If it's raining, it will stop watering altogether. It's intelligent enough to not water your lawn if your lawn doesn't need it. Rachio is EPA WaterSense certified and tested to the industry's highest standards. So it's not going to be wasting the precious resource that we so desperately need here in California. You can save up to 50% on your outdoor watering bill while helping save over 500 million gallons of water nationwide. Just check with your local water provider for rebates up to 100% the cost of a Rachio controller, and then you'll know for real that it's for you. Rachio is made in the United States, and it's currently available at Rachio.com, Amazon, Home Depot, and Best Buy. Now, if you're installing outdoors, you'll need their custom waterproof enclosure, which is right here. This is the Rachio controller, which is, you know, it's nice. Anyone who's ever set up an irrigation system knows what these are. This is where you connect your different solenoid valves, but this gives you the ability to either use it indoor with its standard faceplate or to put it in this outdoor enclosure so that, say, your gardener can get to it. They've really put the design work into making this an all-in-one solution. And as a geek, I think we all should appreciate that. Enjoy your great yard without wasting water or money. Over 500 million gallons of water are saved and counting, and it's all because the Rachio is a smarter way to think about irrigation. Here's what we want you to do. We want you to go to Rachio.com/twit. That's Rachio.com/twit to learn more about the Rachio Smart Sprinkler Controller and to find out if you're eligible for a rebate from your water provider. Change the way you water with Rachio at rachio.com/twit. That's RACHIO.com/twit. And we thank Rachio for their support of Know How. Now, Bryan.
Yeah.
We've had quite a few 3D printers through the no-hole.
Yes, there's two that I can think I've had pretty close contact with, and that's the XYZ DaVinci.
The DaVinci Junior, yes.
The DaVinci Junior, and then the MakerBots.
Right,
and both I have enjoyed playing with both of those, but I feel like you've put them more to the test than I have.
Yeah, I mean, for me, it wasn't. It was sort of a long-term experiment because I wanted to see, will this handle the volume of prints that I will push through it? And Alex, actually, we have a piece of B-roll from the XYZ. I love this printer. You know, it's a $300 printer. It actually works really well. There's a lot of things I don't like about it. I don't like the DRM. I don't like the fact that they break a lot, but they are very economical. And for what you get, it's not a bad starting printer.
No, not at all. And it's pretty easy to use. And I think the only thing you really have to have on hand is a glue stick or some hairspray to make sure the bed sticks to the filament, which isn't, you know, untypical for a 3D printer. But when you say DRM, you mean that the spool that you have to use has an NFC chip that it detects.
Yeah, now I will say, people have cracked it. You can use an Arduino with an NFC shield. People. I have not done it because I am currently under a cease and desist to not tell anyone about it. But people have done it. So if you look for the people, you can find it pretty. And actually, once that was cracked, you can use any filament.
Any filament, which that should be the way it is. But it's that old business model of like ink printers.
Yeah. Sell the printer cheap and sell the ink expensive. This was the printer's $300 when every other printer was going for $1,000.
Right.
But then you have to pay more for the filament.
Yeah. Yeah. But anyway, it's a good printer. I've used it for a couple things and I liked it a lot. So
now you actually had the time to play with the MakerBot.
Mm-hmm.
I kind of didn't because I played with the previous two generations of MakerBots, and I found them to be incredibly expensive and so crazy temperamental. But what's been your experience?
So my experience is that I didn't have to pay for it, so that helps with it. But I think it is like around $1,500 or something like that. But it was really the printer that sparked my interest more in 3D printing because it was so easy to use. It has an interface with a dial that you use the USB, you plug in the USB and play it. And not that you don't do that with the DaVinci, but it just, I don't know, it feels more premium, and like the prints that came out usually came out a lot better. I didn't have as many issues of the bed lifting. I don't know, and I've done a lot of prints on that, and it works pretty well. Yeah,
there are a few things that I really like about that MakerBot that Ron Richards took a look at on the new screensavers.
Right, Aaron Newcomb too.
Yeah, the build platform is much bigger. It's way bigger than my favorite right now, which is the Dremel Idea Builder. As you said, you have less trouble with things lifting off of the bed. I kind of like the design of the printer. It's a beautiful, it's an artistic design.
It is, yeah. And one of the things I really liked about it was mostly like the software interface, and you can take pictures of your print along the way. I think it was probably the easiest for me to calibrate too.
Right.
Because there's only the two dials underneath the bed, and it pretty much, the setup process is pretty automated where it says twist this knob counterclockwise, twist this knob clockwise, and then you're done and it's set and it's ready to go. So
and something else to consider is that the slicing software, because, oh, by the way, slicing is the process of turning an STL file or any CAD file into an actual printable object, because it looks through every layer of the print and says, where does the head need to be?
Right, and if you're using the MakerBot software, at the very end, it'll calibrate your print, and it will show you in a little view of where the head moves at each line of print. So it's like at row height 3, this is where the printer head will have to move to make this. And so you can kind of gauge when you're looking at your model, like, oh, this might not work because the overhang for the head is that it has to travel from this point to this point, which is like the longest distance of the model, and things get messed up.
But what I like about the MakerBot software, though, is it figures a lot of that out. So for example, last week we used Mesh Mixer from Autodesk to do the overhangs, because that's not done in Tinkercad and it's not done in the software for the Dremel Idea Builder. Now that's free software, so it's just another step, but that process is actually built into the MakerBot software. It will generate the supports.
It worked really well for a lot of the projects. Like Karsten Bondi, one of the producers here, printed a skull that had horns coming out of it, and it required a lot of different little supports. It actually looked kind of cool with the supports because it looked like blood coming out of the stuff, whatever.
Wow.
But it took up the whole bed, and it had to build all these little structures. And I think they kind of came out better than some of the structures I've seen on other printers, where it's like those trees that they build.
Yeah, yeah. Of course, the printer that I've stuck with for, 9 months now has been the Dremel Idea Builder. And I know we've shown it off on Know How before, but people keep asking me what printer I like, what printer I got my choice.
Well, you like it so much that I haven't even gotten to play with it yet.
And you will not.
Yeah.
It will never come back to the brick house. But I mean, I've got the last 2 generations of MakerBot. I've got both a DaVinci and a DaVinci Junior. I've got a RepRap and I've got a Robo 3D. And those are all really good printers, but the one I keep coming back to because it's solid is the Dremel Idea Builder. In fact, I had a problem with it once, and they fixed it in like 10 hours.
Wow.
Which I haven't had that from any of the other manufacturers.
The Dremel, is that the one where you can tell that it's set up for dual filament, but they just haven't included that aspect yet? Okay.
And so at some point I will hack that together, but I'm kind of reluctant to do that because that is my workhorse printer, and I don't want to
tinker with it. Yeah.
Just yet. But without further ado, let's go ahead and take a look at a review we did of the Dremel so you get an idea of why I like it so much. Here is the Dremel 3D Idea Builder. The 3D Idea Builder is a first-generation single extruder PLA 3D printer from Dremel, the king of DIY and maker tools. Designed for beginning to intermediate builders, the Idea Builder features solid construction, easy access panels, and a 9-inch by 5.9-inch by 5.5-inch maximum build size. In the box is everything you need to start printing: the printer, build tape, a 4GB SD card, nozzle cleaner, print scraper, USB and power cables, and a spool of filament. Setup takes about 5 minutes thanks to the easy access provided by the removable top and quick release build platform. The filament spool goes into a well in the base of the Idea Builder, and the filament threads through a guide tube into the extruder. Dremel supplies several panels of heavy-duty build tape that is thick enough to be reused several dozen times, and since the build platform has a single hold-down tab, it can be slipped in and out in seconds. After power-up, you can access the Idea Builder's tool screen and initiate the filament auto-load sequence. Every step the printer takes is reported on a color touchscreen that gives you access to all the printer's features, functions, and tools. For proper prints, Dremel has a step-by-step menu-driven procedure for fine-tuning the level of the printing bed. Once the tool has been initiated, the build surface moves up to the extruder, and you tighten or loosen 3 adjustment knobs on the bottom of the build platform until the supplied leveling card just barely meets resistance, slipping between the print surface and the print head. When the hardware is ready, you need to fire up the Dremel slicing software on a Windows OS 10 or Ubuntu Linux computer. I tested the software with several STL files from Thingiverse and found the software to work very quickly. I would have liked more control over print densities and support settings, but overall the software did a fine job in getting objects ready for printing. Once the object is ready to print, the software can send the print directly to the Idea Maker's internal memory, or you can copy the file to an SD card. The Idea Maker prints layers with 100 micron thickness, and it's designed to work with PLA filament only. There is no DRM on the spool, so you can use your own filaments, though that can void the warranty. But you'll either need to wind your filament on one of the Dremel spools or create an external feed, as most generic spools won't fit properly into the filament well. I made over a dozen prints with the Idea Maker and was impressed both by the quality of the prints and the blazing speed. I printed several of my Know How projects and was pleased to see print times cut in more than half over my current 3D printer. Not only that, but I didn't suffer a single jam or misprint during the run. The Dremel 3D Idea Maker is available now. You can find it online for about $900 with a 1-year warranty. You know, one of the things I've liked about that Dremel is it's been printing pretty much constantly since I got it.
And when he says constantly, he means constantly, like
constantly.
24 hours, 7 days a week.
It's always,
yeah.
In fact, I tried to make a device that would automatically like scrape the print surface so that it could start the next one. It worked, kind of.
Yeah, not so much.
And then it made a tribble because I guess the surface wasn't in the right. It just like it did filament in the hair.
I've seen that. Yeah, it looks like a tumbleweed.
It was
kind of.
it was cute.
It was cute. Yeah, right up until you tossed it.
Yeah. Now I will say I prefer to use the Dremel, but that doesn't mean it's the best printer out there. It just means it's the best printer for me. For what I do, for the setup that I have in my lab, for the amount of filament that I push through it, it's worked incredibly well. And I find Dremel stands behind their tools way more than XYZ. I had a problem with a DaVinci Junior, and basically they pushed me back and forth between departments for 4 months until the warranty ran out. So that's why I don't use this anymore. Which is why I brought it to the know-how.
That's part of the price. I mean, how much is the Dremel?
Well, right now you can get it for about $800, but they have a new version. They have the 4D0 version, which does auto leveling of the platform, which is very nice, and it's slightly nicer. I'm hoping to get a unit so I can play with it at some point in the near future.
Right. Yeah, I guess you just kind of, if you want to take a chance and something goes wrong, you won't have the customer service that you would hope to have.
Indeed. Now, in just a bit, I'm going to show you why we've got this printer on the table. We did say we wanted to show you some 3D printing troubleshooting, and that's exactly what we're going to do. If you've ever had problems with your filament getting jammed in your hot end, well, I'm going to show you how you could fix it. But before we do that, Brian, you know what I want to do?
Fix some filament? No, wait, no, sorry.
No,
we're going to save
for
that.
later.
Yeah.
We're going to save that.
You want to thank a sponsor?
I want to thank a sponsor, and it's a sponsor that's been with us for a while, of course. That's DigitalOcean. Now, DigitalOcean is the best way to get your website, your portfolio, your app, your server, whatever it might be, on the internet. They use containers. They call them droplets. It's a way to take everything that you need for that app, for that service, for that website, and put it into this wonderful little software package that can be run on 1 CPU, on 10 CPUs, on 1,000 CPUs. It's the new way of thinking about presence on the internet.
Well, so I guess you might have a greater appreciation for it because you came from an era where you had to really do a lot of that stuff.
Oh, you got to do me like that?
And now I just see this, and I'm like, this is the way you're supposed to do it.
Yes, okay, yeah, rub it in. I do come from an era where you would typically have to like buy the server, buy a space to put the server, buy the bandwidth to connect to the server, and then hire someone to maintain it.
Right.
Well, you don't have to do that anymore because that's exactly what DigitalOcean does for you. Now, DigitalOcean is the premium way for developers to get their work on the internet. It's used by over 600,000 developers, including Twit's Randall Schwartz, Aaron Newcomb, and myself. It lets you deploy and configure your droplets via a streamlined control panel or a simple API. You get to choose your OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD. You could also select from one of the many pre-configured one-click installs, like Drupal, Docker, or Node.js to get up and running quickly, or because they give you root access, you could build the exact infrastructure that you want and need with 100% SSDs in state-of-the-art data centers around the world. DigitalOcean is highly scalable to meet the demands of your rapidly growing application or business, which again means that you could start with just a few hours of usage on 1 CPU and 1 SSD, and you can expand that all the way up to thousands of CPUs across hundreds of locations. That's the power of DigitalOcean. You could also use advanced deployment features like floating IPs for high availability, virtual networking, and automatic API deployment. They've got an extremely active community, which again is one of the things that I always look for because it means they've made their customers so happy that those customers are coming back to help the new people. It's not just a company, it's not just a service, it's a community. And it's so easy to get started that you can deploy your own SSD cloud server in as little as 55 seconds. Don't wait any longer. Try DigitalOcean. They've got incredibly affordable and straightforward pricing with servers starting at just $5 per month, and there's also hourly pricing available starting at less than a penny per hour. But we're going to make it so that you can get started today and deploy an SSD cloud server for free. Just visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code KNOWHOW for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do for you. That's DigitalOcean.com, DigitalOcean.com. And once you sign up, enter the code KNOWHOW in the billing section to get your $10 credit for free. And we thank DigitalOcean for their support of Know-How. Brian, you're probably wondering why we've got this printer, which I refuse to use because it busted on me, up on this desk, and why it's making noise.
Well, I've used it, and this is the one that's been living in the no-hole, and that's kind of a stressful condition.
It's a super stressful condition. Now, one of the things that we wanted to show you is how to fix a very common problem among 3D printers, and that is jams.
Yeah.
You actually had a problem with this.
I had a problem with this. It was really irritating, and it wasn't raspberry jam, so it wasn't Lone Star.
No, it wasn't. What you'll see sometimes is the little gear that advances the filament, it will strip away the filament because the hot end has become jammed with stuff, and it can't force the filament through that little hot end hole anymore.
Right, exactly. That's exactly what happened to me. And then I tried manually just pushing the filament in there, and that didn't work.
Exactly. And
so what's your solution?
The solution is you need to clear it out. You see, what happens over time, especially if you've got something like this. I mean, look. That's dust that we've collected off at the top of this. That's getting inside the printer. It's getting onto the filament. And what happens when it gets onto the filament and then the filament gets fed into the hot end, that dust, that grime, the oil on your fingers, which is why I don't touch the filament with my bare hands, or I wipe it off with alcohol. But that gets into the hot end and it stays there. And eventually it builds up like a layer of plaque. It's 3D printing plaque.
Yeah, and see, to be fair to the MakerBot, I never had a jammed head on it.
Oh, look, I like that shot. That's a good shot.
Padre.
No, sorry,
No.
that's what we're gonna do. So actually what we're gonna do here is I need to go into the utilities. I am going to do a changing of this. Actually, no, I want to clean this thing. Hold on, clean nozzle, there we go. Most printers have a clean nozzle or a clean hot end function.
Right.
And what that will do is it will just heat up the hot end, and then it will allow you to get the gunk, get whatever's stuck in there out.
Yeah, I use like a rag and kind of wipe it off.
Well, I would use something a bit more forceful, like
I see.
This is actually a...
Is that paperclip? I can't see.
No, it's like a piano wire.
Oh.
That's shaped into a little tool. What this will allow me to do is to get it into the top of the nozzle. This is actually the exact size of that nozzle. And I can like force the gunk out of the hot end.
Right.
Now this is one of the ways we're gonna do it. I'm gonna show you how this works. So what it's doing right now is it is heating up my nozzle. I don't know if you can see it. Actually, go to the front view. So right now, oh no, the front view. There we go. So right now that hot end, what it's doing is it's repositioning. It's gonna do its little self-calibration thing it does. And then it's going to heat up the hot end. And once that hot end is hot enough, I can actually take it off of that axis because it's got a quick detach. And I can use this to sort of force everything through the nozzle. So if there's any oil, if there's any dust, dirt, grime, gunk, hopefully I can push it through.
Right, and what will happen is if there's any filament already latched in there, it'll just start to kind of drip out, which is normal.
Kind of gross, but
it's gross, but it's normal.
Now, in certain cases, not even that will work. It's because you've got so much in there, you can't even get this through. I've developed another procedure.
Oh.
And it's with this. This is 28 gauge nichrome. It's piano wire. This is the stuff that if you apply a charge to it, it actually gets very hot, so you could cut through foam.
But I have not tried that.
This is thin enough that what you can do is you can actually put it into the 3D printer, and it's like dental floss. You basically run it back a couple of times,
up and down,
and when you pull it out, the gunk will be stuck to the wire. Right.
Dental floss for 3D printers.
It's heating it. It's 46 degrees. So let this heat up. Yeah, there we go. When the fans turn on, it means it's getting hotter and hotter. What we need is this to be close to about 200 degrees, because that's the temperature at which PLA is going to want to flow through the hot end.
Right.
And at that point, we can force through. And if this doesn't work, I'm going to show you how to use the nichrome.
Okay.
Yeah. When you tried to unstick the print head, did it work?
Eventually. Yeah, it probably wasn't the right way of doing it because I was just trying to force filament through.
Let me guess, at one point it like just spurted out, right?
Yeah.
Like,
yep, exactly.
Yeah, you don't want that because what's happening is you can actually damage like the filament advancing mechanism. But I've done that before. So.
Yeah, wasn't sure what to do, and I could see that it was grasping. It was like trying to pull the filament down, and I was like, well, maybe it's just not getting enough of a pressure. Like maybe it got caught on something, and I just have to kind of force it down.
And you can see that because you see how the filament is kind of eaten away by the wheel. You'll see, it actually looks like it's got a bite taken out of it, and that's that advancing wheel that it's just working on the same bit again and again because the entire assembly is jammed. See how hot this is right now. It's 172 degrees, so this is pretty close.
Getting there.
So what we're going to do is, this has a very cool feature that lets me do, hold on, I have to get out in the front here, lets me do this. So I can take the entire assembly off, and I can detach it from here. Now what I can do is I can put this in here and force it down, and you'll notice I've got material dripping out of the bottom.
Yeah, it's hard to see because it's black and
disgusting.
Gross, but yeah,
Gross.
there's a little bit hanging out.
Totally gross. See, so what I'm doing right now is I'm kind of forcing down all the gunk that might have accumulated in that barrel, and it's forcing it out at the bottom. Now, this got most of it. I've got a little piece here, but I want to make sure that it's clean because when this cools down...
Never mess with a dirty tip.
Yeah, watch the tip. So I'm going to take my nichrome wire, and actually what I'm going to do is I'm going to let it cool off. So I'm going to tell it I'm done.
And it's okay just to set it on its side like that?
Oh yeah, that's fine. That's fine.
No problem.
Yeah, and what I'm going to be able to do is I kind of want this to start cooling off, so that the material will stick. Because I want to be able to stick. See how it's coming out of the bottom?
Yes, I can confirm it's coming out of the bottom.
There we go. And then when I pull it back up,
oh, you got some stuck to it. Gross.
Exactly.
Yeah.
Now that's the material. That's like the filament that has been ground together with dust and dirt and human dead skin cells.
How often do you have to do this for this XYZ?
It
depends.
It depends. This one, the one that I actually gave to the no hole, I cleaned it out right before I gave it. So this is actually still relatively clean.
Okay, yeah, because I've only done a couple of prints.
Right, and with the Dremel, I've never had to do it because I actually keep it enclosed.
Right, and the MakerBot is open to the air, so I don't know if it would be an issue at some point, but it hasn't been.
So let me go ahead and just put this back in. So all I'd have to do is I'd have to reconnect my filament tube and reload, and I'll be good to go.
Cool.
So if you find yourself with a jammed printer, that's how you fix it.
I wish I had known.
With a paper clip or some nichrome wire.
Cool.
And this is cheap, by the way. This is like $2 a roll. So get yourself a bunch.
Nice.
Yeah. Well, folks, I know that this was a lot of information for you to take in a single episode. We want to make it easy for you to follow our instructions. Brian, where do they go?
Well, if you want a step-by-step list of all the very nice notes that Padre has made, you'll want to go over to twit.tv/KH. Not only will you find the notes, but you'll also find links of any of the stuff that we had on the show in case you needed to purchase some of that, and also handy links for subscribing.
Sorry, I'm trying to get the filament jizz off though.
Why don't you just cut it?
That's actually, yeah.
Get rid of it.
Also, don't forget that you could find us in our Google Plus group. Just go to Google Plus and look for Know How. It's probably the best place to find out what's going on in the community with the Kitas, the know-it-alls.
The Kitas.
It's a fantastic place for you to post project pictures if you want input or to help people with their projects. And it's also the perfect place to put images, videos of your project, so maybe we can put it on Know How.
Definitely, or if you have other solutions for or tips that you have for fixing 3D printer problems. But you know, if you're in Petaluma or Northern California, you should stop by the studio. We have an audience today.
We do. We have an audience of thousands, actually, right now.
Not here.
I mean,
oh, there's the audience.
He has multiple personalities.
And that is totally not my brother
that's
who
a Burnett.
came to visit.
Yeah,
See,
that's actually a Burnett without mental issues. That's so weird,
right?
It's
well,
so strange.
That's 1 in 3.
And you know what?
Isn't bad.
Just looking at him, I can see. I mean, if you go back to that shot, Alex, he's got game.
He's got game.
Which I'm like, he can't be a Burnett.
Well,
so.
That's why he doesn't work here. And he was nice enough to be our studio audience.
Don't forget that you can also find us on Twitter. You can find me at twitter.com/PadreSJ.
And I am at cranky_hippo.
And you can find the third member of our team, our director,
there he is.
Bill. That's Bill. Bill over there. Bill.
Oh, yeah, in the corner.
Bill Brundle. He's always faithfully back there pushing the buttons, making sure that we're on time.
He knows how to push buttons.
Excuse me, Padre. That's Alex Gumpel.
No, it's not striking a chord. I think I would know that.
Yeah, you can just call him Champ.
I mean, Bill, if you want me to
Whatever
call
you
you
say,
Alex,
sport.
I'll call you Alex. But you can find him twitter.com/Anelf3. That's ANELF3. Until next time, I'm Father Robert Ballecer.
I'm Bryan Burnett.
And now that you know how,
Go fix it. Go printer troubleshoot it.
go stick a thing through your hot.
That was so hard to get through.